Hey guys, I've been getting a lot of questions about calculating average atomic mass, so I thought I'd make a quick video going over the equation together and then solving one practice problem. In order to follow along with us, you're going to need 4 things. You're going to need a pencil or pen, you're going to need a piece of paper, you're going to need a calculator, and you're going to need to pull up a periodic table, which we have linked a periodic table on the homepage of our Schoology course, or you can simply just look up one online. So if you need to retrieve those materials, go ahead and pause the video now and press play once you are ready. Okay, now that you have those materials, let's get started. First, let's talk about what average atomic mass even is. It is called the average, keyword average, atomic mass, because this is the average mass of all of the isotopes of that particular element. And different elements have different numbers of isotopes. Some elements only have 2 isotopes, some have 4, some have 7, some have 12. Every element is different in the number of isotopes that it has. So let's follow along with this video, and you can write down this equation as I do. Let's start off our equation with writing average atomic mass on the left-hand side. And average atomic mass is in units of AMU, which stands for atomic mass units. Now, the first part of the equation then, on the right-hand side, is vital information about the first isotope of that element. And vital information includes the mass of that isotope as well as the percent abundance of that isotope. Now, the percent abundance tells you how commonly occurring that isotope is. If you have a high percent abundance for that isotope, such as maybe 80%, that means that 80% of all of the atoms of that element are that particular isotope with that unique mass associated with that isotope. Whereas if you have a low percent abundance, such as only 5%, then that means that only 5% of the atoms of that element are of that particular isotope. Now, because this mass and percent abundance that we just wrote is pertaining to one particular isotope, let's label it that way. So I would just label this to help us remember. These 2 pieces of information pertain to isotope number 1. But when we're calculating average atomic mass, it means that there's 2 or more isotopes. So we need to add more isotopes. So we're going to add a plus sign, and then we're going to do the exact same thing, but this is going to be for isotope number 2. So we're going to have the mass of isotope number 2, and then we're going to have the percent abundance for isotope number 2. And then let's label this accordingly as information related to isotope number 2. Now, we're not done yet because we have to add one more thing to this equation, and that is to divide everything on the right-hand side by 100. And there is our equation. So on this next slide then, we're going to use this equation to solve for average atomic mass. And here is the practice problem. It says determine the average atomic mass and then the element's identity. So you can see here that we have 3 different isotopes of this unknown element. We have isotope number 1, isotope number 2, and isotope number 3. Now, notice that in the equation we just wrote on the previous page, I only had 2 isotopes, but we can always add more simply by adding another plus sign and then multiplying the third isotope's mass by its percent abundance. We can do that for however many isotopes the element has that we're working with. That's the beauty of this equation, is we can adjust it accordingly. So let's go ahead and set up the information in this table, and we'll put it into our equation. So again, I'm going to write average atomic mass on the left-hand side. And let's start working with isotope number 1. So this is information about isotope number 1 right here. Notice that we're given the mass number, which is a whole number, and then we're also given the exact weight. The exact weight is going to appear in decimal form, whereas the mass number is going to be rounded to a whole number. We're going to go ahead and use whichever number is more specific in our equation. So I'm going to go ahead and use the exact weight of 27.9769 when I am mathematically calculating my average atomic mass. And I'm going to go ahead and do that now for isotope number 1. So I'm just going to copy that number down from the table, 27.9769 AMU, since this is a mass. And then the percent abundance for this first isotope is 92.23%, which, by the way, means that of these 3 isotopes, the first one is by far the most commonly occurring, since 92% of all of the isotopes, or atoms, I should say, of this element are of the first isotope's mass of 28. All right, now let's do the second isotope. So I will copy the exact weight exactly as it appears in the table, 28.9765 atomic mass units, times its percent abundance, which it looks like it occurs 4.67% of the time. And then I have one more isotope. It's the last isotope. I'm going to have to add another plus sign, and then I will copy down the exact weight exactly as it appears in the table, 29.9738 atomic mass units, times, I'm kind of running out of room here, but okay. And this third isotope is the least abundant isotope. It only occurs 3.10% of the time. Now I do have to remember that I will need to divide all of this over 100 once I put it into my calculator. So I'll give you a moment then to go ahead and plug these numbers into your calculator and see what you get. And at this point, you can pause the video if you need some time. Okay. Hopefully you were able to plug those numbers into your calculator, and your final answer for the average atomic mass, I'll just put it up here. Final answer for the average atomic mass of this unknown element is 28.085 AMU. Again, we're going to write AMU because anytime we're talking about mass of atoms or isotopes or ions, we'll go ahead and put AMU since that is the correct unit. So this number allows us now to identify the element's identity. Because remember, there was 2 parts to this problem. Not only did we have to solve for the average atomic mass, but then we had to use that average atomic mass to figure out what element is this. And here's how we can do it. We can use the periodic table to match the average atomic mass that we just calculated to the average atomic masses listed on the periodic table for each element, and we can figure out what element this must be. So take a moment right now, pause the video if you need to, look over all of the elements on the periodic table and see if any of the elements have 28.085 listed as the average atomic mass in their element box. Okay. You should see that silicon is the element whose average atomic mass is listed at 28.08, which means that our unknown element is silicon. So this is how you can figure out elements' identities. All of the elements on the periodic table have average atomic masses listed, and remember, average atomic masses are the average mass of all of the isotopes of that element. And it does take into consideration which isotopes are more commonly occurring, so which ones you find more often, versus the ones that are very rare, the ones that you hardly ever find. And that's why this is called a weighted average, because it has factored in the frequency by which you come across those isotopes. I hope that this helps. Thank you for listening.